Okay, solving more complicated rational expressions. When you have a bunch of different denominators like this, the way that you crack it is you find your lowest common denominator and you multiply everything by it. In A, this is pretty straightforward because they both have the same denominator, x. The way you attack this is you multiply the entire thing by x, both sides. That gives you x times 4. It gives you x times 2 over x. The x's cancel so that all that survives is a 2. And on the right side we get 6x. And the x's cancel and we get a 3. Now, subtract 6x from both sides to clean this up. 4x minus 6x is minus 2x plus 2 equals 3. And then we subtract 2 from each side. And we get minus 2x equals 1. Divide by negative 2, x equals minus 1/2. What did I forget? Non-permissible values for this? There's only one and it's easy. X cannot equal 0. This solution isn't 0, which means it's okay. In B, our lowest common denominator is x minus 1, so we multiply the entire thing by x minus 1, left and right sides. So we get this x times x minus 1 plus, here we get 2 times x minus 1 over x minus 1. The x minus 1's cancel, and so all that's left is a 2. And on the right side, we get 4 times x minus 1. Expand this, x times x times negative 1, plus 2 equals 4x minus 4. Subtract 4x from each side. And add 4 to each side. Okay, so we subtracted 4x, we added 4. Here we are with a quadratic. Factor this, and it'll factor to x minus 2, x minus 3 equals 0. Those are numbers that add up to negative 5 and multiply to positive 6. So we get two solutions. X can be 2 or x can be 3. Are those both okay? Non-permissible value for this would be x minus 1 is not allowed to be 0, which means x is not allowed to be 1. So yeah, neither of these solutions is 1, which means they're all right. Last one. I'm going to need a little extra space for this one. Plus 1 over x minus 1 equals 2. Okay. The denominators, or the common denominator for this will have to contain an x plus 1 and an x minus 1, so we have to multiply through by both. We multiply the entire thing by x plus 1, every single term, and we have to multiply x minus 1 through the entire thing. There we are. So the x plus 1's cancel here, the x minus 1's cancel here, nothing cancels over on the right, and we get, what, 3 times x minus 1? Here we get 1 times x plus 1. That's fairly easy. And on the right, I actually have to FOIL this. We have x plus 1 times x minus 1. So x times x minus x plus x, those cancel. And 1 times negative 1 makes negative 1. So we have to finish cleaning this up, and I have to start writing smaller because I'm running out of room. 3x minus 3 plus x plus 1 equals 2 x squared minus 2. Add up things on the left side. 3x plus x gives me 4x. Negative 3 plus 1 is negative 2 equals 2x squared minus 2. Throw everything to the right-hand side, and we get 2x squared minus 4x. And we get negative 2 here plus the 2 that came from the other side. Those actually cancel. So this ends up being an easier quadratic than we're used to. We don't have to do decomposition or anything like that. We can just come at this with a common factor. 2x comes out. That leaves us with x minus 2 equals 0. So our solutions are going to be either 2x equals 0, which means x equals 0, or x minus 2 equals 0, which means x is 2. Those are our two solutions. What's missing? Non-permissibles. Don't forget to check them. Up here we had x plus 1 equals 0, so that means x can't be negative 1. And x minus 1 equals 0, so that means x can't be positive 1 either. Neither of our solutions is negative 1 or positive 1, so both of these should be all right.